Chemistry, Mrs. KJ here, going over part 3 of the Unit 2 lab. Had to think for a second there. And we're going to start out with me saying that I made a mistake. It happens to us all. So if you remember when we mixed the chalk with the water, do you remember what it did? It turned tan. And I said, it's just a glitch, and because really chalk and water don't react. Here's where my mistake comes in. Think about if you have a piece of paper and you get it wet. It gets darker. If you have chalk and you get it wet, it does get darker at first. So I think what they were trying to show was that it was getting darker, because now look here. This is what it looks like after the water evaporated. And what do we notice about the color of our chalk? Our chalk is back to the original color. So we had it change color, but then it changed back to the original color. So if we scroll down here in the record here after evaporation, we would write that we have white chunks. So it's kind of like that one question where it said, if you have a spoon and you heat it up and it turns red hot, but then you let that spoon cool back down and it's the original color of the metal, is that physical or chemical? Well, in that case, it's physical. You had a temporary color change, but it's still the same substance. That's what we had here. We had a temporary color change, therefore it is physical. So if you look down at our next set, it says, use your observations from above, write P for physical and C for chemical in each box. If you choose chemical, tell what in your observation made you choose chemical. All right, so I would have to write for chalk and water, I would have to write physical. Because, yeah, we had a color change, but it changed back. All right, so I wanted to make sure I really explained that one to start out with. Then we can go ahead and look through the rest of our observations. And again, you're filling them in the after evaporation chart, except for the oil. The oil does not need to evaporate because it's not gonna. All right, so we have, for this one, this is where we put our chalk and oil. And for chalk and oil, I simply wrote no change. You don't want to write nothing because nothing can be misconstrued as, well, is it empty? Is that what you mean by nothing? So we want to specifically write no change. All right, so for number 3, what would we write down for our observations? In well, we call this well A. It's like battleship. We call it A3 because it's row A, column 3. So in A3, what would we write down? We would write down that it's back to white chunks. So that's what we started with. So if it's back to what it started with, that vinegar just evaporated off, we have our original chalk. So if we have the same thing we started with, what would we call that, physical or chemical? That one would be physical because we have what we started with. We have our chalk yet. All right, 4 and 5, you can tell they look just like they did originally, except now it's solidified. So, which I know you can't see on the screen, but that's what would happen if it evaporated. You'd have the same stuff, except it would be solid because the liquid from the vinegar evaporated. So, dark brown could see craters for bubbles. You can see where there's craters. And for the mixture of chalk and sodium hydroxide, I put light brown, could see craters for bubbles. So then you want to use this information and you want to go down and say, okay, for chalk, well, we said with water it was physical. We had no change for number 2, so physical or chemical? Physical. Number 3, we still have that white. So if we still have that white, what are we going to put for that one? Well, it's still the chalk, so we put physical. The citric acid, well, it's definitely chemical, right? But what would we put for Y? Why, or what observation do we have that supports the fact that it was a chemical reaction? So for this one, and remember only for the chemical, you have to write more. I would say bubbles and color change. And then for number 5, A5, I would say the same thing. I would say bubbles and color change. So that's how you'd fill out that first column. So now you're going to scroll back up to record observations here after evaporation. And we'll go to our table and we'll go ahead and do the NaCl. So our NaCl you can put what down for the first one? I would just write white chunks again. And for well D2, for D2, again, no change. And then go ahead and write down your observations for D3, and write down your observations for D4, and write down your observations for D5. All right, let's go to our next one. Our next one is KCl, which is potassium chloride. Go ahead and write down your observations for 1A, which is the water in KCl. Write down your observation for 2A, which is the vegetable oil in KCl. Write down for 3A, which is the vinegar in KCl. Write down for 4A, which is the citric acid in KCl. And write down for 5A, which is the sodium hydroxide in KCl. All right, so now we're going to go to our bottom row, which is our baking soda. And so again, write down your changes for baking soda and water in D1. Sorry, your observations. Write down your observations. Write down your observations for D2, which is vegetable oil and baking soda. D3, which is baking soda and vinegar. If you remember, I said, I was really surprised it didn't react in that. But look, now that we looked at it later, we can tell that, oh yeah, something did happen. Maybe it just took a while and it was on such a small scale we couldn't really see it. But something definitely happened here, right? Because this is different than our control, than our water being added. So, yep. And then write down your observation for D4, which is citric acid, and your observation for D5, which is the sodium hydroxide. All right. And then we'll go over to our last well. So sugar is our top row. And let's write down our observation for A1, sugar and water. Write down your observation for A2, vegetable oil and sugar. Write down your observation for A3, which is sugar and vinegar. Observation for 4A, which is sugar and citric acid. And lastly, 5A, which is sugar and sodium hydroxide. All right, and then this last set of wells was with vinegar. So this is vinegar and water. Now, I really want to make a point to show you this. Vinegar and water, as you can see, there's some little brown chunks there, right? Okay, so your first thought might be, oh, it had a chemical reaction because I have brown chunks. No. Okay, here's why not. All we did was add water to vinegar. All that water does is dilute vinegar. It makes it weaker. Just like if you make Kool-Aid and you add way too much water, you know how it doesn't taste as good because you diluted it too much? You spread out the Kool-Aid mixture too much. That's all water does to vinegar as well. It just dilutes it. Therefore, when it evaporates, and in real life, if you evaporate vinegar, there's a little bit of remaining. There's a little bit of like almost crusty powder remaining from the chemicals inside the actual vinegar. So this one is our control. This is what it should look like if it's a physical reaction. So I bring that up because normally, what color were the physical reactions in this lab? Normally they were white, but that's because we started with a white powder. Here we started with vinegar, and all that's left is some of the remnants after evaporation. Remember, evaporation is a phase change. Here it comes. Phase changes are physical. Therefore, the control in this case has the brown chunks. All right, so that's a physical change. Okay, let's go ahead in your next well. You know, we said that this one was a lighter color than the other ones. So definitely feel free to say that this one at this point, we think it actually might be chemical. And I'm telling you that one because, you know, this one's kind of tricky. It's like, well, did they just not mix and it's not showing well on the screen? So maybe chemical, question mark, lighter change, but really not sure. All right. So you can literally copy this into your box for the vinegar and the oil. We put chemical, it's different color than the other mixtures with oil, but not sure based on limited ability to make observations. So this is what you can write down for the vinegar and vegetable oil. All right, this one was just the vinegar with the vinegar, and so I ended up having to redo this because my lab didn't save right for me. So I didn't do this one at all. So we're just going to ignore this one. So there's nothing left over for the vinegar and vinegar, because really it should have been the same as vinegar plus water, because it's just a little bit of remaining chemical inside the vinegar that cannot evaporate. All right, so let's look at 4 and 5. Now remember, this is our control. This is what a physical change with vinegar evaporating would look like. This is what happened in well 4. Write down your observations. And this is what happened in well 5. Write down your observations. All right. So then you're going to proceed again and go to that bottom table and tell me if each one is physical or a chemical reaction. If it's chemical, make sure you tell me why or how you knew based on the observations that it was a chemical reaction. If it's physical, you can just write in the letter P for physical.